Let's solve this problem. They have given that logical address space equal to 64 KB, physical address space equal to 64 KB, and page size equal to 2 KB. Now we need to find out all these things. Number of bits in logical address, number of bits in physical address, and all this. Okay, we need to find all these things. Now before doing this, first let's convert these values in terms of powers of 2. For example, this is 64 KB, right? 64, this is 2 power 6, this is 2 power 10 bytes. So 2 power 6 into 2 power 10 is 2 power 16. It is nothing but 2 power 16 bytes. Similarly, this is also 2 power 16 bytes. This is nothing but 2 power 10 into 2, which is nothing but 2 power 11 bytes. 2 power 11 bytes. Now, what is the number of bits in logical address? That really depends on what is the total size of the process, right? See, in case if the size of the process is 2 power 16 bytes, then we need 16 bits in logical address, right? Now when it comes to number of bits in physical address, it depends on the physical address space. In case if the physical address space is 2 power 16 bytes, then the number of bits in physical address is nothing but 16 bits. Number of bits in page offset field. See, this really depends on what is the size of a single process, single page or single frame, right? See, in case if the let us take the physical address, okay? Let us take the physical address, and we know that it is 16 bits. And we know that in physical address we will be having frame number and frame offset. Frame number and frame offset. Now they are asking how many bits will we have in frame offset field. See, frame offset or page offset, right? Both will be same because size of a page and size of a frame is always same. And so number of bits in frame offset field and number of bits in page offset field will both be same. Fine. Now they have given that this is 16 bits. Also they have given that page size equal to 2 power 11 bytes. If page size equal to 2 power 11 bytes, then obviously frame size is also 2 power 11 bytes. And so our page offset field or frame offset field will have 11 bits. Now this is 16 bits and this frame offset field is having 11 bits, right? Now the frame number field will have 5 bits. Okay, if this is 16 bits and this is 11 bits, then the frame number field will have 5 bits. Now in case if the frame number field is having 5 bits, then what will be the number of frames? Number of frames is nothing but 2 power 5, right? It is nothing but 2 power 5 frames. Now in order to find the number of pages, we need to consider the logical address, right? Similar to physical address, we need to consider logical address. And also we know that size of logical address is 16 bits. Okay, size of logical address is 16 bits. Also we know that, see, coming to logical address, we will have two fields, right? One thing is page number and another one is page offset. And we know that page offset will have 11 bits, right? In case of frame offset equal to 11 bits, obviously page offset will also have 11 bits. If page offset field is having 11 bits, then the page number field will have 5 bits. Okay. Now if page number field is having 5 bits, then the number of pages is nothing but 2 power 5. Now how to find out the page table entry size? See, page table entry size really depends on how many bits do we need in order to represent a frame number, right? How many bits we have in frame number field, and here since frame number field is having 5 bits, now in every page table entry we will be actually representing the frame number, right? And so we need 5 bits in our page table entry. Okay, every page table entry. Now what about the page table size? See, we have a page table, right? We have a page table and our page table will have lot of entries, right? Our page table will have lot of entries. Now what is the size of this table? That really depends on how many entries we have into size of a single entry, right? Number of entries we have into size of a single entry. So page table size is nothing but number of page table entries into size of a single entry. Size of a single entry. Now what is the number of page table entries? Number of page table entries really depends on how many pages our process has, right? Which means for every page we maintain a page table entry. Since we have 2 power 5 pages, we will have 2 power 5 page table entries, and size of every entry is nothing but 5 bits. Okay, size of every entry is nothing but 5 bits. So 2 power 5 into 5 bits is the size of the page table. In case if you want, you can convert this into bytes. How? By dividing by 8. Okay, in case if you divide this result by 8, you will get the result in terms of bytes.